Hi there. We're learning today how to find the missing radius of a semicircle as well as of a full circle. The beauty of this question that there are mensuration skills along with algebraic skills are brought together in this question. Let's see how this is applicable. So the question says, a semicircle has a radius. The radius is given to us in this question for the semicircle as an expression r plus 4, and its area is the same as the area of a circle where the radius of the circle is r. Where the radius of the circle is r. Write an equation in terms of r. Okay, so there is a semicircle. You can draw a little sketch for a semicircle where the radius, which is the distance from the center to the circumference of the semicircle, is r plus 4, is the expression r plus 4. The area of the semicircle is the same as, it means it is equal to the area of a circle with a radius r. So let's draw the circle. Again, the radius is the distance from the center to the circumference. If we're gonna translate this sentence in particular, where it says that the area of the semicircle is equal to the area of the circle, we're gonna start this way. Or area of semi is equal to area of circle. Okay, so the semicircle is basically pi r squared divided by 2. But I want to reinforce the idea that a semicircle is actually a sector. It is part of a circle. And the area of a sector is the angle of the sector over 360 times r squared times pi. And the area of the circle is pi r squared. So, let's do that. So, the angle that is opposite to the arc of the semicircle is actually 180 degrees. 180 over 360 times pi times the radius to the power of 2. And the radius of the semicircle is given to me as an expression r plus 4 or 4 plus r to the power of 2. Perfect. Which is equal to pi r squared. And the radius of the circle is given to me as r. Now, all what we need to do, there is an equation here, as you can see, with one unknown, which is r. So we need to figure out how we're going to bring r to one side of the equation. But first, okay, let's apply opposite operation before we get rid of brackets. We have a denominator, which is 360. So let's multiply the whole equation by 360. Remember, get rid of the denominator by multiplying all by the denominator. The denominator here is 360. So we're multiplying each side of the equation by 360. So on the left side, the 360s are gone. Okay, as following. Now, we want to isolate 4 plus r all to the power of 2 before we get rid of the brackets. So we're going to divide each side of the, so we're getting rid of 180 and pi. So we're going to divide the whole equation by 180 times pi as following. I don't want you to find the value of 180 times pi. Because basically we know that it's going to be a recurring decimal number. So we can just divide by 180 times pi. So the 180 and pi on the left side of the equation are gone. As following. So, and on the right side of the equation, 360 divided by 180 is 2. Pi is gone with pi. Pi in the denominator is gone with the pi in the numerator. So what's left? It's 2 times r squared. Now we can get rid of the brackets. 4 plus r is to the power of 2 is equal to 4 plus r in brackets times 4 plus r in brackets as following. And 2 times r squared, we can write it as 2r squared. So when we multiply two brackets, remember, we take each term in the first bracket and we multiply it. We take the first term and we in the first bracket and we multiply it by each term in the second bracket. And then we take the second bracket, the second term in the first bracket, and we multiply it by each term in the second bracket as following. 4 times 4 is 16. And then 4 times r is 4r. So we finish the first term, which is the 4. Let's take the r. R times 4 is 4r, and r times r is r squared. As following. Now, we want to transfer all the terms to one side because the equation is basically like terms added or subtracted from each other is equal to a number, which is 0. So, let's bring the 2r squared to the other side of the equation or to the left side of the equation by subtracting 2r squared from both sides of the equation as following. Now, when we subtract, it's gonna be on the left side. So the right side is 0 and that's what I want. The left side, 16, there is no other like term to 16. So 16 is gonna come down. 4r and 4r, when we add, we know that they are like terms because it's an r. So we only add the coefficient 4 and 4 and we do not mess up with the power. The power is only telling us if they are like terms or not. We only change the power when we are multiplying or dividing expressions. But when we're adding or subtracting expressions, the power is only there to tell us if they are like terms or not. So 4r and 4r are added to each other. We do not mess up with the power because the power is 1 and 1 to r. So we keep it as is and we only add the coefficients. So 4 plus 4 is 8. And then r squared minus 2r squared. Again, it's like plus 1 minus 2. Plus 1 minus 2. Different signs we subtract. And we take the sign of the greater number. So 1 minus 2, the answer will be minus 1. So it's going to be minus r squared as following. Now, remember, we need to always keep the coefficient of r squared, x squared, n squared as a positive number. So what we're going to do in this case? We're going to multiply the whole equation by -1. So, and when we multiply it by -1, we're going to multiply each term in the equation by -1. Meaning, -1 times 16, it's going to be -16. -1 times 8r, it's going to be -8r. -1 times -r squared, it's going to be positive r squared. And -1 times 0, anything times 0 is going to be 0. So, that's how it's going to be. Let's rearrange it now. We want to always keep our quadratic equation as AR squared plus BR plus C is equal to 0, or AX squared plus BX plus C is equal to 0, because this is the general form of the quadratic equation. So let's rearrange it. So it's going to be R squared minus 8R minus 16 all is equal to 0. Now we have an equation in terms of R that is equal to 0 and we need to find R. So how we're going to do that? Please stay with me and have a look at how I'm going to do this. Okay, so there is this general formula where R is equal to fraction line minus B plus minus square root of B squared minus 4 times A times C all under the square root all over 2A. Accordingly, we're going to have two values of R. Before I carry on, we need to go back to the presentation, and A in this case is 1, B is negative 8, so A is the coefficient of R squared or X squared, B is the coefficient of R or X, which is negative 8, and C is the number in its own, which is negative 16. So A in our case is equal to 1, B is equal to negative 8, and C at last is equal to negative 16. Let's substitute. So one time we're going to substitute here as plus and here as minus. So minus B, so it means minus, this is part of my equation, and the value of B is negative 8. Plus under square root, it's going to be negative 8, which is the value of B, all to the power of 2, minus 4 times the value of A is 1, times the value of C, which is negative 16. And remember, all under the square root and all over 2 times 1. Now, here we're going to say minus 8. Instead of the plus, it's going to be minus and the square root of negative 8 all to the power of 2 minus 4 times 1 times negative 16 all over 2 times 1. You need to insert this in the calculator as following. So you put at first the fraction button and you write minus 8 plus, and then you press square root, and then you press the button of x squared and you put the bracket. Inside the bracket you write minus 8, get out of it, and then you say minus 4 times 1 times negative 16. Go down to the denominator using the arrows in your calculator, and 2 times 1, get out of it and put the equal, and then SD, the decimal. So here, if you want to put your answer correct to 3 significant figures, it's going to be 9.66. centimeter, meter, depending on the question, because the radius is the distance from the center of the circle or the center of the semicircle to the circumference. Let's go to the second one. So you're going to put the fraction button and then minus 8, and remember it's minus now, square root, and put the x squared button, put the brackets, inside the brackets put minus 8, get out of it and then say minus 4 times 1 times negative 16, go down to the denominator and it's 2 times 1, and then get out of this and put the equal, put the decimal. The value here is negative 1.66, and this value, because it's negative, it's going to be rejected because there is no distance in a that is negative, so this value is rejected. So if we go back, so 9.66, if we go back to the presentation, so R for the radius is going to be 9.66, and for the semicircle, you're going to say 9.66 plus 9.66 plus 4, and the value will be 13.7 centimeter. I'm gonna say please watch this video again if you find it difficult, and keep on trying to solve it on your own until you master it, because there are so many beautiful skills in here where you had to write an equation based on the given information in this question. And you had to apply multiple steps of opposite operations to have an equation where the unknown is brought finally to one side, and you ended up with a quadratic equation where you had to use the general formula of finding the unknown in a quadratic equation. Thank you so much for watching, and always remember that only practice makes it perfect. Please watch this video a couple of times, and I'm gonna thank you once again for watching, sharing the link of this video, and subscribing to my YouTube channel.